Olden days, before smartphones, VR headsets and hoverboards, humans had to make their own fun, and they did this by meeting up with friends and doing fun stuff. Like swinging off banks. And if that doesn't seem exciting enough, you can always add a quadruple backflip to your bank swing. He literally hasn't thought about social media for like 3 minutes. Oh, nice matching bandanas.
Remember to lean back and pull your knees up to your chest.
But before you go big,
there you go.
It's always best to start small. Perfect. Perfect-ish. Swinging on a rope is one of those pursuits that has been providing mankind with entertainment for thousands of years. And what have we learnt? Well, letting go above water is easy. Landing back on the bank is a bit trickier. To avoid mishaps, our man must ensure there is a high coefficient of friction between hand and rope in order to maintain a grip. Since he and the rope form a pendulum, he must start from high enough to ensure he has enough gravitational potential energy to return him to a safe landing spot. A good swing onto a bank should also factor in the tensile strength of the rope and branch, the trajectory, and most importantly, an exit strategy. Most failures when swinging onto a bank are due to errors in judgment. So if you want to land back on the bank with dry socks, you need to know all about trajectories, tensile strength, and gravitational potential energy.
Here we go.
He's got his gravitational potential energy about right, but his exit strategy needs work. He should have let go about there, and he doesn't.
Oh, Dad!
And now there's no way back. Now, remember, the structural integrity of a swing is always a key consideration.
I'm not going to risk it. Oh, no. God, that's why I didn't do it.
There's a single point of contact between rope and stick, so when he swings, the high pressure at that point leads to a structural failure and a very sore back. His helmet suggests he's well prepared, but has he calculated his trajectory? Well, I think that answers that question nicely. The helmet protects his head from knocks, but not knees from stinging nettles or his butt from getting wet. What's your assessment?
That was a fail.
Yeah, I concur. So next time you fancy being the king of the swingers, don't forget your science. And definitely don't do this. Because it really hurts. All right, let's see how that first guy's getting on.
Good.
Looks like he's still stuck.
Can you build up momentum somehow? Yeah. No, Dad, you got to wrap it.
Your son's science is a lot better than your swinging. Right, now it's time for us to look at the natural world, and today we're going to be studying something that we can't live without, but could sometimes do without. I am, of course, talking about rain, because while it can bring untold joy to the uninitiated, it can often be quite disruptive. Although if you have a massive tractor, you should be just fine. Did you know that the greatest rainfall recorded in a 24-hour period occurred on Reunion Island in 1966, when 72 inches poured down on the Fok Fok Plateau? That's enough water to completely submerge the average American man. With rain like that, I don't think an umbrella is going to be much use, but understanding the science never hurt anyone. Rain is part of the hydrologic cycle that begins when water evaporates and forms clouds in the atmosphere. Water vapor condenses on micrometer-sized particles of dust floating in the atmosphere to form cloud droplets, just a few hundredths of a millimeter in size. Within the cloud, droplets collide and combine until they're heavy enough for gravity to pull them down. Below the cloud, as long as the droplets are big enough to survive evaporation in the warmer air, they will eventually reach the ground as precipitation. So, rain comes about because of evaporation, condensation, and precipitation. But the science doesn't stop there, because after it falls, it can stick around on the ground and become a pretty effective lubricant. And the most important thing to understand about a lubricant is that it can lead to a loss of friction. The rainwater forms a thin layer between the player's feet and the ground, meaning when they attempt to kick, the standing leg does not have enough friction to resist the torque from the swinging leg, giving their friends a hearty chuckle. I always find that high-speed parking in the rain is best avoided. And that's why. Car tyres are designed to displace water, but there's a limit to the amount of water that can be displaced, and lower friction becomes a problem on a corner, where lateral forces are the order of the day. Of course, the heavier the rain, the more water there will be on the ground, and with more water, high speeds lead to hydroplaning and a severe loss of friction. Perhaps in future, this couple should stick to public transport. Coming off the bike at nearly 70 miles an hour, the low friction between their leathers and the wet road meant it took 9 seconds to stop, more than enough time to contemplate the properties of rain.